Alright, so in chapter 1, section 9, we're talking about inverse functions. And there's a nice visual way to see if a function has an inverse. For something to be a function, it has to pass a vertical line test. So if we took a line and went across, does it hit more than once? To have an inverse function, it not only does it has to be a function, so a vertical line across, it only can hit one point, but also horizontally. Like, so right here, it would touch a couple points if I had a horizontal line going up this coordinate plane. And so this one would not be a function because it touches twice. Some of the other pictures, let's look at another function. Like this one touches twice here. This one, it passes the vertical line test and a horizontal line test. So this one would have an inverse function. So that's one way to determine if a function has an inverse. Now, algebraically, if the last section we were doing a composition of functions, if you compose two functions and you get an x, then they are inverses of each other. So if these two functions are inverses of each other, when we compose them with each other, our value will be x. Visually, let's look at a couple inverses. Excuse me. So if I have a function, 3x plus 2, and so a nice line, right? This function passes a horizontal line test and a vertical line test. Doesn't touch any place more than once. So if I was looking at the inverse function of this, which I'll show algebraically in a supplemental video, if I had x minus 2 divided by 3, these two functions are inverse functions of each other. So if I had some values for this function, let's find some values for this function. And let's use a table. So if I have a table that I put in here, and let's just do 1, 2, 3, and let's find out what its y value is. And so there are those points. Well, when I do a table for my inverse function, I'm going to call it g of x. We will notice that its table looks similar to its inverse's table. I'm going to type in 5, 8, 11, and 14. Let's see what my y values would be for g of x. Oh, x2, sorry. So we notice that if I plugged in my y values that I found for my f of x, I plug that for my x and my g of x, I get out my x's from over here. They give the opposite variable. So one is taking x and solving for y, and one is taking y and solving it for x. So they're inverse functions of each other. So again, I typed in the 1, 2, 3, 4, it gave me the 5, 8, 11, 14. If I plug in these values for my inputs, my outputs would be these values. Also, graphically, inverse functions, they are they reflect this y equals x line. So it's a reflection from that y equals x. So visually, if you typed in y equals x and you saw that it reflected, you could verify something was an inverse. All right, another one to look at. Besides number 3, I have number 6. I wrote down. So this one would be finding an inverse function. First, does it have an inverse function? This one's linear, so unless you are a vertical or horizontal line, you have an inverse function. So it absolutely does, and we will find that inverse function here in a supplemental video in just a second. And then I wanted to talk about a word problem number 11. It has your wages $10 per hour plus 75 cents for each unit produced per hour. So your hourly wage is determined by this thing. Now if we found the inverse function of this, like my hourly wage is y, the number of pieces is x. The inverse function would say, if my hourly wage is this amount, how many pieces did I make? So it would be solving for the other variable. Another one that they talk about in the book, I believe, is Celsius and Fahrenheit. It all depends on which variable you want to solve for. So this is in context to a word problem. Again, it's just solving for the other variable. It is the inverse function. So I will make a supplemental video for number 6 so we can actually find an inverse function algebraically.